Hello and thanks for watching Best Maths Tutors. We're continuing to cover the questions from the 2019 Edexcel Foundation Tier Paper 1. Topics we're going to cover today are going to include highest common factor, three-dimensional drawings and transformations. And if you find this helpful, we'd love it if you would like our video and subscribe to our channel. So starting off with this question 24, we've got to find the highest common factor of 72 and 90. And what that means is it's the largest number that will divide into both 72 and 90 without any remainder at all. The easiest way to do this is to write a factor tree for them. So if I start off with 72, then what I'm going to do is I'm going to look for numbers which will divide into 72, so factor pairs. So we can see that if I divided 72 by 2, I'd have to times that by 36 to get back to 72 there. So 2 times 36 gives us 72. And what we found is a prime number because we couldn't divide 2 by anything else now to get anything smaller other than itself. So 2 is where this particular branch ends, and we now continue to work on the 36. So if we divide 36 by 2, we get 18, and I can circle the 2 because that's also a prime number. And I can divide the 18 by 2, and that would give me 9. And then if I divide 9 by 3, what I would get is, so 3 being a prime number, I'd also get 3. So that means that the tree is completed there. So because 3 is a prime number. So what we can say from that is that 72 is actually equal to all these numbers that I've circled multiplied together. So it's 2 times 2 times 2 times 3 times 3. And I could actually write that as powers as well of these numbers. So I could say that's 2 to the power 3 because there's 3 2's there, times by 3 to the power 2. So that's a nice sort of compact way of writing it. If we do the same now for the 90, so I'm just going to start off by dividing it by 2's as long as I can. So 90 divided by 2 will give me 45. Now, we can't actually divide 2 into 45 because it's an odd number. So I'm looking for numbers that will divide into it. And 5 will divide into 45. And 5 is actually a prime number, so I'll circle that. And that would mean I'd get 9 if I divided 45 by 5. And if I then try and divide the 9 by 3, then that's a prime number, and 9 divided by 3 also gives me 3. So that's a prime number. So I can write the 90 as equal to 2, and I'm going to go in order from starting with the smallest number. So then 3 times 3 times 5. And if I wanted to, I could put that into a nicer sort of format. So I could say that's 2 times 3 squared times by the 5. So these are now written. This is called product of its prime factors. And to be a product of its prime factors, what that means is product means multiply. So if we multiply all these prime numbers together, then what we would get is we would get 72. So 72 is written as the product of its prime factors. It's written like that. And now to find the highest common factor, the HCF, that stands for highest common factor, what we do is we look for numbers that's in both of these lists. So we can say, well, we've got a 2 that's in both. So I'm going to write that down, 2. And we've got a 3 that we can pair off with this 3 here. So times 3. And we've actually got another pair of 3's as well. So we're looking for things that's in both. So we've got another 2 3's there. And that will actually give me my highest common factor. So if I work that out, I've got 2 times 3 is 6, times 3 again is 18. And that's my highest common factor. if we continue with the paper now, question 25 is a question about doing a 3D sketch of this shape, which has been drawn in plan, front elevation, side elevation. So I'm just going to sort of explain what that means, plan, front elevation, and side elevation. So imagine we've got a house. I'm not the best artist in the world, but there we go. Imagine we've got some house sort of shape like this. Then the plan would mean looking at it from the top. So if you could imagine, if we looked at the top of this, I'll just put a little chimney on the top so we can also get a bit better idea of what I'm drawing. So from the top view, what we might just see is the roof like this, and we'd see the little chimney. So that would be the plan looking from above. And then the front elevation would be looking from that direction. So imagine I've got a little window on there as well and a door. Then the front elevation would actually look like this. So we can see there's the front of the house, and with the window and the door and a little bit of the chimney that we'll be able to see there. And the side elevation is looking from there. So we've got plan, front, and side. So that was my front elevation. And if I did the side elevation, that would look fairly simple. That would look like just a triangle on top for the roof, and I'm not drawing anything on this wall here, so it would just look like that. So that's to give you an idea of what a plan, side and front elevation look like. So in our case, what this would have to be would be a cylinder. So we can see that if we had a cylinder, it would look like this. And we can see that if we look directly on top of from this cylinder, that would give us the plan view, which would be this circle. And the front elevation, so if we look directly into the shape, we just see actually a rectangle, as we would see if we looked in the side direction. So we can see that that's the correct shape to draw it in 3 dimensions, but it's asking us as well to put the actual dimensions on it. So because this is a centimetre grid, then that's telling me that the distance across there is the number of squares that are across, and so that's going to be 4 centimetres. And actually this is also 4 centimetres here, and the height there is going to be the number of squares, so that's going to be 5 centimetres as well. So we need to put these onto our diagram so we can see that we need to put in that that's 5 centimetres, and actually it's got a diameter, so that distance going across the circle there, of 4 centimetres. Put a little arrow there so we can see a bit more clearly. So that's 4 centimetres. So that's that one completed, question 25. And if we move on to the next one, question 26, then what we've got is we've got a transformation. So that just means when we're moving shapes around on a grid like this, transformation. And it says, first of all, we're doing a reflection in the x-axis. So we're taking shape A and we're reflecting it in the x-axis. So to do that, we can take any point on this shape A, and the x-axis is the horizontal axis here, and whatever distance it is to the horizontal axis, so we've got crossing 2 squares there, then we need to cross another 2. So that's going to go to there. So this point here, that corner, goes to there. And if we do it for each one of the corners, so this one moves down by 2, so it's going to move down a further 2 on the other side of the horizontal axis. So that gives us this line. So this line would look like this. and then we just need to know where this point's going to go. So because it's 1, 2, 3, 4, 5 squares to the horizontal axis, it's actually going to be the same on the other side. So 1, 2, 3, 4, 5, and that's going to end up there. So this corner is now here. So if I just draw that in, there we go. So that's shape A transformed there. So I'm just going to call that A dash. Sometimes it's written as, just to show that it's the transformation of that. And now we're going to do, so that was a reflection we've just done. We're going to do a translation. So that's a translation is a different type of transformation. So for transformations, we've actually got 4 types. And those 4 types of transformation are a reflection. We've also got a translation, so that's the 2 we've got here. And we've also got a rotation, and we can have an enlargement as well. So these are the 4 types of transformation. So what we've been asked to do is look at a translation. Now for a translation, the shape stays the same way up. So as we can see, the base of this shape is still in the same position. It's just that it's actually moved, and it's moved by a vector, as we can see. A vector means a line. So if I pick 2 points which are the same, this point here and this point here, and draw a line between them, that's actually the vector the shape's moved. And so what that is in the x direction, we've moved 1, 2, 3, 4, 5, 6. Because it's to the left, we've actually moved -6 in the x. And the top one of these numbers is the x one, and the bottom one is the y one. So we've moved by -6 in the x, and because we've moved down by 1 in the y, and that's -1. So that is the vector that we've moved by. So that's the translation. So we could say that C is equal to -6 and D is equal to -1. And we've done it. So I hope that's been helpful to you. And if it has, we'd love it, as I said before, if you would like our video and subscribe to our channel. And also hit the notation button, the notation bell, which I think appears at the bottom, and then you'll be notified for any of our videos that appear. So thanks for watching.